Hi everyone, I'm Santiago Rodriguez, and this is Fernando Lamela, and we will introduce you our solution, Green Cyclops. Okay, Green Cyclops is a computer vision platform that yeah. Green Cyclops is a computer vision platform that, with the support of 5G, edge computing, and artificial intelligence, can retrieve information for the surrounding environment, analyze it, and take decisions and perform some actions related with the natural environment surveillance and smart agriculture management. The information sources can be fixed cameras, drone cameras, or even IoT devices. We have two parts. The edge part, where the application okay, where sorry. Okay, we run the inference at the edge. We have one instance application that can run several pipelines running different models from different video streams. We have two, a cloud management, and we can see all different models of our solution. We have the make services used for retrieve information about the location, the power and quality of the signal, and so on. We have the AI and IoT instances that process information from the cameras and the IoT devices, and with the inference produce some events and alarms that are sent to the cloud. At the cloud, we have a model repository with pre-trained models that can be used by the instance at the edge. So when a new information source appears, it sends a message to the instance at the edge, notifying the location of the video stream and the object to be detected. The edge retrieves the model to be used, generates the pipeline in real time, and produces the results that are sent to the Green Cyclops management at the cloud.
Okay. As the detections are made by the inference models that we deploy in the application instance at the edge, events are generated. These events, as well as events from the IoT hubs, where we retrieve information, pass a correlation process to raise an alarm. With this alarm, at the same time, we can raise different actions in real time, like, for example, request to a drone to move the gimbal or to approach, to go closer to the location where the alarm is being produced. And at the same time, this alarm is sent to the management side that we have deployed in the cloud. In this management side, we can raise and group these alarms into issues, and we can have all the information about all the scenarios we support in the Green Cyclops solution. That can be, for example, fire prevention, deforestation, information, or different use case related with smart agriculture, like the detection of wildlife intrusion into production land. We have in this management side all the information retrieved from the alarms with the snapshots, the relevant snapshots from the detections of the different inference models we are running on the edge side, and we have all the traces of the applications we have running at the edge. These traces and the monitoring of this application allow us to maintain the SLA of these applications running at the edge, having the capability to move this application between the different kind of edge. We can configure different kind of resources, different kind of paths. we can, with this path, we can have actions to request more flights as a real-time action to retrieve more information from a location with a specific path. We can set new devices, UAVs or fixed cameras or another kind of IoT hubs that can be configured in the solution. And we have information from the radio retrieved from the APIs. Because we have integration with the APIs from the FC part. We are using or reusing all the work from the Akraino project in three kind of themes: the AI Edge, the 5G MEC system, and the smart cities. From one of them, we retrieve or we are reusing information or taking information related with the use of Edge for surveillance and security scenarios. In another one, we are using, for example, we are taking how to process or use the 5G connectivity to process video streams. And in another one, the inclusion of different kind of sensors or IoT hubs for smart agriculture. We are using different APIs from the ETSI, like location information or radio network information, or the APIs for registering the applications we deploy at the edge. And we have, as I say, a backend where we can manage all the SLAs related with applications we have in the different sites of the solution. And that's all.
Do you guys have any questions?
Hi, thank you.
Hi.
Thank you for the introduction. So I have a question. You mentioned that you're using the GSMA SBI. I think we talked a little bit yesterday, the east-west bound APIs. Can you describe a little bit more?
Yeah, we are using the SBI. Excuse me. We are using we have integration with the Etsy APIs. We are using the SBI's definition from the GSMA, for example, to retrieve analytical information for the NWDAF. And we are using for federation. In the demo, we don't have a federated scenario regarding the edge. We can define in the sandbox in order to extend the demo. But we have integration with the east-west-bound interface definition of the GSMA that are defined in the OPG and in the OPAC to be capable to put this solution in a scenario where we can use another edge nodes from another providers or another operators we can work with.
Okay, so potentially you can support multiple operators network.
Yeah,
okay.
We try to.
Thank you.
I think this is very scalable. And when you do the Alpha Edge, AI Edge Blueprint family, did you change any code or you just download and use as it is?
We are, for example, when we change the application between edge nodes, we are monitoring two kind of events. One events that are from the retrieved from the application, like the evolution and the uses of the resources in the edge of the application, and the network events, what we can retrieve from the APIs, for example, in this case from the Etsy. We can have in one case to request to the same node for more resources. If no more resources are available at this node, we can move or make available the application in another node. There are another use case that is UAVs that are moving, and we detect, for example, that the latency are not the desired latency we request in the SLA when we try to deploy the application. And in this case, we deploy the application to be used for this drone in another node. We have tests to move not only the application and to move the context of the user, but in this demo we don't have this use case deployed. This is only a a use case that we have in the lab, and we need to work more on that.
One more.
Hi, thanks for the presentation. So, yeah, it looks like you are federating a lot of different kind of devices in your solution. So, just wonder, like, do you have a plan to productionize it after the hackathon? And what are the major challenges you would think of if you want to make it at a large scale?
Yeah, our intention is to move this proof of concept to a solution that we can deploy in an environment. In fact, we are talking with an operator in our region and some customers that can be interested, like governments, for example, with the scenario of fire department, or fire detection, or fire prevention. Yeah. And our plan is to continue with the roadmap of the development of the solution. In fact, we have a split in the development of the solution. We have, from one hand, the green CYCLOPS solution that is composed by a set of devices and principally software and applications. The application that we deploy at the edge and the application that we deploy at the cloud for the solution, the whole solution, end-to-end solution. And we have another development that is in charge of all the, in brackets, magic of the maintenance of the SLA of the application in the edge nodes. One of them, the last of them, is cross. We can be used by Green CYCLOPS or another solution we have, or another partner can have. And Green CYCLOPS we have the orientation to be used to protect the environment, or to be used to digitalize agriculture or smart or first-class industry. Like this.
The first slide, just
Thank you.
I'll see intro.
All right, thank you, team 2. Appreciate it. Great job. Great job.